So ladies and gentlemen, in this video we are going to talk about relations and functions. The first thing we need to talk about is what is a domain and what is a range. Well, the domain are the x values. They are the inputs, whatever we put into the equation. They are independent, meaning we can select any number we want and put it in there. And for if you have an ordered pair, we are going to list. So for this example down here, we are going to list this this is called roster notation. And it just kind of has a curve, a pointy arrow, and another curve. So like a parenthesis, a pointy arrow, and another parenthesis. So when we do this example down here, we'll use that roster notation. And then for graphs, so like this top example, we will use an inequality. And this is very important. When you're using an inequality for domain, which is your x values, you need to scan your graph from left to right. And it will look like this. It will be the smallest number, and also sometimes that's negative infinity if your graph goes on forever. And then you will either use less than or equal to, depending on the graph touches it. If the graph touches it, it's less than. If the graph doesn't touch it, it's less than. If the graph touches it, it's less than or equal to. And we're going to use x because it's x values. And then it will either be less than or equal to our biggest number. And that's kind of confusing probably right now. Just write it down and I'll show you what I mean when we do some examples. Next, our range. Range is going to be basically the opposite of all of that. So if domain is x values, range is y values. Domain was the input, range is going to be the output. These are the numbers that you would get once you put whatever x in and do the work in your head or your calculator. This would be what it gives you. And they are dependent because they depend on what you put in for x. You pick your x, but then the equation or the math makes this dependent. And again, for ordered pairs, same thing. We'll use our list of roster notation, parenthesis, arrow, parenthesis. And then in graphs, okay, so for graphs, we're going to still use inequalities, but for range, we are going to scan from bottom to top. And then again, we're going to use the smallest, and will either be, oops, that's too many L's. It will either be less than or equal to, but this time, this time it won't be x, it'll be y, less than or equal to the biggest number. Okay, so domain and range. Now, functions. Functions. When I have a function, a lot of your questions on this assignment will be asking if something is a function. So to tell if it's a function, each x or input can produce only one y or output. And again, this may not make sense right now. Just write it down. I'll tell you what I mean in a second. So an easier way to tell if each x produces only one y, you look at your x values. The x values cannot be repeated. Okay, so if I have 5 comma 1 and 5 comma negative 2 in the same thing, that cannot be a function because they cannot belong both. They can't both at the same time belong to a function. Okay, so another way to tell, so let's pretend real quick that I was going to graph that real quick. So just pretending with me, we go over to 5 and up 1, and we go over to 5 and down negative 2. So looking where those ordered pairs end up, they end up, so this is 5, 1, and this is 5, negative 2. They end up right along a vertical line. So a shortcut, if you have a graph, a graph must pass the vertical line test. Okay, the vertical line test. Sometimes we just call that the VLT, must pass that to be a function. Okay, and the vertical line test says, off the screen again, the vertical line test says any vertical line can only hit the function that's graphed one time. So if it hits more than one time, so like on this one, it hit 5, 1, and it hit 5, negative 2, so this would not be a function because a vertical line, boom, boom, hit it in 2 different spots. So it can only hit one place, and then it can't hit your picture anymore, whatever function you have graphed. All right, let's try some examples. So in this example, first of all, we need to draw a couple more things. This has arrows. This is also a coordinate plane, so it has arrows. So first of all, we're going to look at the domain. So domain, get the right color, that's purple. So to do domain, we are going to scan from left to right. So the leftmost number is negative infinity, and the rightmost number is positive infinity. So as I put my pencil down and I scan from left, the first thing I hit is here. So this place right here on my graph, it's got an arrow. It's got an arrow, which means it continues on and on forever, meaning it will not stop. So where it begins is negative infinity. So negative infinity is where it begins because it would continue on and on and on forever. When we use infinities, you always use a less than. You cannot use the or equal to because you can't ever touch infinity. Okay, domain is x. And then as we go to the right, the last thing we touch is this up here. Again, an arrow. So arrows mean infinity. And we're going to use less than again because we can't use or equal to with it not being able to touch infinity. But since it goes on forever, those arrows mean we're going to have infinities. Then range, we're going to scan from the bottom. And the bottom of a graph is negative infinity. The top of the graph is infinity. Oh, that's a really bad looking infinity. If you can't draw an infinity sideways, just turn your paper and make an 8. This graph, as I go from the bottom and I go up, if I look here, the first thing I touch is the bottom of that curve. Now that is not an arrow. So since I'm not hitting an arrow, I actually have to use this number. So this ordered pair right here is 0, 1. That's the ordered pair right here, right there. Because it goes over 0 and up 1. You can see a little 1. Well, you can't now because I drew over it, but you could have before I put that dot there, that point there. So do you think we should use the 0 or the 1 if we're talking about range? Well, in talking about range, we always use the y value, so we're going to use the 1. So range is going to start at 1. And again, it's not an infinity because this is not an arrow, it's an ordered pair. Now, is the graph actually on 1? Is it touching this 1? Yes. So I have to use less than or equal to because it's touching it. And range uses y. And then at the top, if I go up to the top of my graph, I end with arrows. So that means it goes on forever or infinity. And this side gets a less than, but not equal to, because you can't touch infinity. Okay? Then is this a function? Well, is this a function? So I'm just going to put some pins vertically on here. If you look at these two pins, do they ever touch my curve, my graphed parabola, in more than one spot? Well, if I draw any vertical line, it will touch it in one spot, but never again. Over here, one spot, never again. So is this a function? Yes, because it passes the VLT, or vertical line test. Next one, on this next one, instead of having a graph, I've got some ordered pairs listed here in roster notation. So it's 8, 0, 0, 4, negative 2, 4, and 4, 2. First thing I need to do is domain. So domain for this one, if the ordered pair is 8, 0, which one of these exists in the domain? Well, the 8 does. 8's in the domain here, 0, negative 2, and 4. So the domain is just the x values. So let's figure out which one is the smallest. So negative 2, then 0, then 4, and then 8. So I listed them from smallest to largest, but I only use the x values. Now, to do range, I'm not going to use the x values. I'm going to use the y values. So y values looks like my smallest one here is 0. So 0, 2, and 4. So that's my range. Now, is this a function? Well, to tell if it's a function, I need to look at this. So my first x value is 8. To tell if it's a function, the x values cannot be repeated. So I need to look and see if any of my x's get repeated. So 8, does it happen again as an x value? Nope. Move on to 0. Any of my other x values 0? Nope. Negative 2. Any of the other ones negative 2? Nope. Negative or positive 4. Any of my other x's? So on the left, positive 4? Nope. So is this a function? Nope, wrong color, Mrs. Black. Yes. Yes, it is. Why? Because none of the x values repeat. They all are a one and done. All right, last one about domain, range, and whatnot. So again, we need to put some arrows on here. This is a coordinate plane, so it needs arrows. And this needs arrows because it continues on forever, but the clip that I got didn't have arrows on it. So domain, we put our pin down and we scan from left to right. So as I start at the left, boom, this bottom, well, it's not really the bottom, this left side of the curve is what I get to first. So here, this point looks like I went over 2 and up 0. So which part of that am I going to use for domain? The x or the y? Domain is x's, so I'm always going to use the x value. So I hit it there. Did it touch negative 2? Is that actually an ordered pair on the graph? Yes. So less than or equal to. Domain uses x. Now if I continue to scan the graph, the right side has these arrows. So that means it's going to continue on forever, and it's going to be to infinity on that right side. And remember, you use less than because you can't touch infinity. Now to do range, we start at the bottom. And this time I have an arrow, first thing I hit. So negative infinity is less than y. And then if I go up to the top of this graph, the last thing that my pen touches is also an arrow, positive infinity. And just a little cheat code, if you have infinity on the left, it will always be negative because it needs to be the smallest number. And if you have infinity on the right, it will always be positive because it needs to be the largest number. So if you have a negative sign, it would only ever be on your left-hand side. You never see it on the right-hand side. And then, is this a function? Well, let's figure it out. So we said when we have a graph, it has to pass the vertical line test. So if I draw a vertical line right here, yes, drawing lines means sound effects. So if I draw a line, does it hit this shape more than once? Well, it hits it right there, and it hits it right there. So is this a function? No, it is not. And that is because it fails or does not pass the vertical line test, because a vertical line can hit it in more than one spot, so it is not a function. All right, flip it over. Uh-oh, got a lot of writing bleeding through. Okay, flip it over. So on this next thing, we need to talk about mapping diagrams. So in a mapping diagram, write down mapping diagram. In a mapping diagram, you will have a box, and you will have the inputs or the domain, and then they will have arrows that point somewhere along another box that will have other numbers that are the outputs or the range. UTS. Okay. OUTPUTS. Sorry. Didn't spell very well. Okay. And our arrows go from the input, which is the domain, and then it points to its own output in the range. Okay, so what do you mean by that, Mrs. Black? Well, let me show you. All right, in this little table here, it's kind of confusing because it says years and number of inductees into, I don't know, Hall of Fame somewhere. But then again, it says year and number of inductees. These two columns really should be down here, but to save space, I threw them up there. Okay, because Math Excel has one like this. Okay, so let's make this a mapping diagram. So it says, let 4 represent 2004. So if I draw, and you can draw it vertically or horizontally, it doesn't matter. But I'm going to draw it vertically. First one, 2004, it said make it be a 4. 2005, I'm going to make that a 5. 2006 is my next number. Then 2007, now up to the next one. Oh, 2007 again, so I don't need to add that again because I already have a 7. 2008 and 2009 and 2009 again, so I don't need that one again. Okay, then my range, or the number of inductees, I think I made that too small. Looks like the smallest number is 13. Next biggest is 27. Next biggest is 85. That's a big jump. Then 92. And then 105. Hopefully I didn't leave any out. Okay, so then to get the arrows, you're going to take whatever this one says and give it an arrow to that one. So 2004, I start my arrow here and I draw an arrow to 13 because that's how many were in 2004. 2005 needs an arrow to 27. 2006 is going to break up my pattern. It needs an arrow down to 105. 2007 needs an arrow to 27 as well. And then 2007 again needs an arrow to 92. 2008 needs an arrow to 85. And 2009 needs an arrow to 92 and to 105. Okay, so now actually getting the domain is really easy. The domain was all this stuff that was over here in this first box. So 4, 5, 6, 7, 8, and 9. And the range, again, not too bad, it's everything that's in my second box. So 13, 27, 85, 92, and 105. Okay, then it says, is this a function or not? Well, this one's a little trickier. So is this a function or not? To tell if it's a function or not, you look at the inputs, the x's, and they can only have one output. So if you notice here, 7, see how 7 has an arrow to 27 and 92? That means it goes to two different numbers. It has two different outputs. So is it a function? No, because 7 goes to, what is that, 27 and 92? And actually 9 goes to 92 and 105, because 7 and 9, which are one input, has two outputs, and it's only allowed to have one. So each input, each one on this left-hand side, is only allowed to have an arrow to one number over here. Now, do I care if multiple arrows point to 92? No, I don't care. But you can't have more than one arrow start from a number over here. Okay. So let me just write that down. So does this make it not a function? So if I had 5 that went to, I don't know, 27, and I also had a 7 that went to 27, that's fine. This could still be a function. I only care about where the arrows start from, not where they end up. Okay, so they can point to the same number, they can't start from the same number. So if you have two arrows that originate at the same place, not a function. Okay, so real quick, how do we graph this? If I was going to graph these, my ordered pair would be 4, 13. I would graph 4, 13. I would graph 5, 27, etc., etc. So I'm only going to graph this one. So if I go over 4 and up 13, and then I'd put a dot there. And then same thing for 5, 27, wherever that would be. It would get just an ordered pair, just 1 point. Okay, so your graph would kind of look like a scatter plot. It would just have points, point, 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 point. You just have to make sure that 4 goes to 13, 5 to 27, okay, etc. Next, function notation. Okay, function notation we have to learn because back in the day, y'all did y equals 2x plus 3, and that's what most of your graphs were. Most of your equations were y equals something. Well, in Algebra 2, sometimes we have more than one graph on a coordinate plane. Like we might have 2 or 3. So we have to use something called function notation. So if you look at these two, really the only difference is instead of the y, we use this f parentheses x thing. So we read that f of x, f of x. So this would say f of x equals 2x plus 3. And we do this so then we have a function named f. We could also have one like g of x equals something else, h of x equals something else, j of x equals something else. So we can have more than one function on a coordinate plane and still be able to talk about which one is which. Okay? F of x is used instead of y. Oh, f of x is the output when x is the input. Okay, so just like we put a number in here and then we get whatever, we'll put a number in here and get whatever. Okay, so if it says f of 10, so my equation is 2x plus 3. What this means is anywhere there was an x, this is the function with an x in it. So this means my function f when there's an x in it. If you change that to a number, it means get my function and put a 10 in there. So take out the x and replace it with a 10. Okay? Take out the x and replace it with a 10. So what this does is it asks us to find the output when the input or the x value is 10. Okay? So f of 10, 2 times 10 is 20 plus 3. So f of 10 equals 23. So what we do to do this, we replace the x with a 10. So in this case, the input was 10, so the x value was 10, the output was 23. We can also rewrite that as an ordered pair, 10, comma 23. Whatever we put in is the x, whatever you get out after you do the math is the y, or output. Okay, so let's do some of these. And yes, I know there's fractions. You can do it. I believe in you. G of x equals negative 1/3 times x. So this first one says find g of 7. So I have g parentheses, and instead of x, I'm going to put a 7. And then I have negative 1/3 times 7. Okay, so my input or my domain is 7. So I've got, let's see, g of 7, negative 1/3 times 7. So just like we did in fraction practice, I need to multiply fractions, but this 7 isn't a fraction. So to get it to be a fraction, I put it over 1. So my numerator now is negative 1, and this one's numerator is 7. So that's negative 7. And then this one's denominator is 3, and that one's denominator is 1. So 3 times 1 is negative 7/3. Okay? So g of 7 equals negative 7/3. And if you wanted to change that to an ordered pair, it would be 7, comma, negative 7/3. Okay, next one says find g of 36. Find g of 36. So same thing, g of 36, and we're going to put that, the 36, everywhere we had an x. So 36, 36. Okay. G of 36, and I have negative 1/3. I'm going to make the 36 a fraction by putting it over 1. Okay, so g of 36, and again, to multiply fractions, you multiply straight across. So negative 36 divided by 3, and then we have to see if that will simplify. So 36 does, in fact, divide by 3. So negative 36 divided by 3 gives me negative 12. So g of 36 is negative 12. So that means my ordered pair would be nope, Mrs. Black, you did it backwards. 36, negative 12. Whatever's in the parentheses is your x, whatever's over here is your y. Okay, now this one's a little tricky. It says if g of x equals 10, find x. So this one's crazy because what it wants me to do, it didn't give me the input. So it didn't give me the x to put in here. It gave me this side over here. So what it wants us to do is replace the g of x with 10 and solve for x. Okay, so I had g of x equals negative 1/3 x. But it wants me to take out that g of x and put in a 10. So 10 equals negative 1/3 x. Okay, so now what I have to do is get the x by itself. So the only thing in front of the x is a negative 1/3. So I could divide both sides by negative 1/3, but we learned in fraction practice that it's easier to keep it, change it, flip it. So instead of dividing by negative 1/3, I'm going to multiply by negative 3 over 1, which negative 3 over 1 is just negative 3. So on this side, I'm just going to make it a negative 3. So that cancels with this. So on this side, all I will be left with is an x. And on this side, 10 times negative 3 is negative 30. So that says my x would be negative 30. So I can double check my work and make sure if I take negative 1/3 times negative 30, does that give me 10? So a negative times a negative, 1 times negative 30 is positive 30. 30 divided by 3 is in fact 10. Yep. So there we go. That is my answer.